In last class, we discussed about I think this activity, right? So we discussed about when that this acid will be shows the properties of acidic property only in the presence of water and all. This activity we explained. Okay, so we discussed about we taken two type of litmus paper. One is took in the we passed the dry HCl gas to the I think in case of dry litmus paper, and one more we discussed about wet litmus paper. Okay, so as we discussed in the case of wet litmus paper we observe that there is a color change actually, right? Color change because as we said that, see, in case of when there is an acid, the presence of moisture, when we taken the wet litmus paper, because of this presence of water it produced something called hydronium ion and Cl minus ion. Actually these are the responsible, I mean H3 O plus ions or H plus ions, these are responsible for the acidic character. Okay, this is what we discussed in the last video. Okay, right now we are going to discuss about next topic, which is called as dilution. So what happens actually dilution? I think we discussed about even alkali also. We can see the diagram. There is a diagram here. There is something else they given about the structure. So you can see the warning sign displaced on containers containing concentrated acids and bases. So why this is so? Just to see the activity here. Take 10 ml of water in the beaker. Add few drops of concentrated H2SO4 to it and swell the beaker slowly. Touch the base of the beaker. So in this case, actually, it is as it is going to be an exothermic in nature. So definitely, the base of the beaker is going to become warm. Okay, just remember, and changes temperature. Definitely, there is a change in temperature, increasing in the temperature. We can say here. And is this as an exo or endo? Definitely, it will be an exothermic. Repeat the activity with the sodium hydroxide. Repeat activity sodium hydroxide means which is NaOH, which is an base also. Okay, let me discuss what happens actually in case of dilution. We try to understand here. So what does it mean by dilution actually? First case, you remember, dilution is nothing but we are taking the acid, which is you can say concentrated acid, and we are adding to the water, right? So it won't form H3O plus ion, or we can say H plus ion and Cl minus ion. But this process actually this is called ionization. So when we are adding acid or base to the water, first thing is ionization is going to take place. This is first to remember. Now after you can see first anyway ionization is going to take place. Next when you are taken, so when we are taking in terms of units volumes, actually units in terms of number of ions per unit volume. Suppose you think like this is beaker, you think, and here we have think like I took here around 20 ml of concentrated HCl. Okay, 20 ml of concentrated HCl I'm taking. Okay, 20 ml concentrated HCl. Okay, this one what I'm doing actually, I'm going to add to the I'm going to add to the beaker stimulator. Okay, let's do some. I'm taking the another beaker where it is contain 90 ml of, not 90 ml, think like 80 ml of water. Okay, 80 ml of water. This is here now. This is water, no? That will be called with. It's a gray blue color. Okay, 80 ml of water we have. Now you see here. Let me think like in the 20 ml of HCl, there are 20 HCl molecule. HCl molecules are there. It means that they have 20 H plus ions. Now, This I'm going to pour. I'm going to pour into the 80 ml of water. 80 ml of water, and think. So here definitely what happens here. So this HCl molecules will be spread everywhere, right? Here and here and here. You can just think like as let me write with the other. Just let me think like this is radical. Just think like this is an HCl molecules. Okay, HCl molecules. See, they are everywhere. I mean, through the solutions, we can able to see the HCl molecules, and as we said upside, HCl will not be remains as HCl now. Now in the water, formed waters are either H3O plus ion or H plus ion plus Cl minus ion. See, these Cl minus ions will be and H plus ion, H3O plus ions will be everywhere. Now from here, if I'm taken 20 ml, from here I'm taken 20 ml. Now tell me, is 20 ml in 20 ml? Is it 20 plus ions are there? Answer is no. Why? Because now HCl molecule is spread everywhere. That's why what we can say in dilution, in dilution. So just so what I can say in dilution, I can write as number of H plus ion, or we can say H3O plus ion per unit volume. What is unit volume? How much you took here? We took here 20 ml of HCl. Here we took 20 ml of HCl. Unit volume is decreases. Decreases. It may be in case of HCl, or it may be in case of NaOH, or it may be whatever may be the solute. So you know very well what is the difference between solute and solvent in this. Uh, can you comment which is solute and which is solvent here? Yeah. Okay, now this is about dilution. Okay, so dilution, you remember here what happens, number of H plus ions per unit volume is going to decreases, and one more thing is what's that ionization process is going to take place. Now when come to the dilution of acid or bases, when come to the dilution of acid, so try to understand. Here one more interesting thing is here. So again, you should draw something else like this. This is on beaker or container, whatever you want, you think. Okay. Now this is one more. This is also one more. You can say this is also okay. Now here I'm taking H, HCl, which HCLs are concentrated HCl. This one, think like this will be an water. This is H2O water. Now I can add H2O to the HCl, or I can add concentrated HCl to the water. Now let me color it then so that it will come to know. Okay. So this is acid, right? This is acid. Which color we give? This is acid, right? So think like here is acid. This is an acid. Okay. Now here is acid. And what we are doing? We are adding. Hmm, we are adding here what? So we are adding here water. Okay. Think like it's full of water is there, and pouring. Okay, just think we are pouring water. This is one diagram. Now here we have what, sir? We have water. Okay, here we have full of water. Okay. Now what we are doing? We are taking. Okay. Now I am what I am pouring here. I am pouring acid. What is the color of acid, sir? Yes, we took here. Not that is not permanent color actually. For your understanding, I am taking here. Now we are taking what, sir? We are taking here acid. Now the question is, see, in both the cases we are going to mix acid and bases, right? This process is called what? This is called dilution. Now tell me which method is correct. And one more thing is, this process is what, sir? Exothermic. Okay, exothermic in nature. Okay, now see, try to understand. Suppose if I am pouring here water, as it is exothermic in nature, here heat is going to produce. Similarly, in this case, here is heat is going to produce. This is something called what we are calling as local heat. Local heat. Now see, suppose if we are pouring water, heat is produced. So what it makes, it will make this heat will be transferred to the next acid molecule. This here acid molecules are there. No? These acid molecules because of heat, they will flash out, splash out here upside. Okay, and they will maybe causes what's up burnings. Now, see, in this case, when we are adding the acid to the water, here is also heat is going to produce. Now, here is some more, what we can say, heat absorbers are there. Which are the heat absorbers? Are nothing but H2O molecules. H2O molecules will absorb heat. That will be transferred to the next molecule of water. That way, these water molecules are going to absorb the heat. That's why this is correct method it seems, and this is a wrong method. Then how we should dilute, sir? We should add the concentrated acid to the water, not water to the acid, not water to the acid. Okay, try to understand, because reaction is what, sir? Reaction is a exothermic reaction. It is an exothermic. That's why this is right method. Which methods are should add the acid to the water, not water to the acid. Clear no? I hope so you got the concept. And one more thing is, in this process, what happens, sir? In this process, ionization is going to take place. That you remember. Now come to the next concept. So after this one, you can see there, in case of base, OH minus ions will be produced. Now I think let me discuss about this questions actually. So they given the here why do HCl and NaHNO3 show acidic character in the aqueous solution, while solution of compound like glucose and alcohol do not show the acidic character. Simple thing is what, sir? They can't. See, acidic character is because of what, sir? Because of H3O plus ions, or we can say H plus ions. Okay, these ions are not produced in case of these. They can't produces produces what, sir? Ions. Which ions are these ions? Which are responsible for the acidic character. Now see, why does aqueous solution of acid conduct electricity? Because they produce what, sir? If I take an HCl in the aqueous solution means what, sir? There is an water. In the presence of water, H plus and Cl minus ions will produce, and this ions will make the circuit into complete circuit, which make the bulb to glow, as we discussed earlier. Okay, now why does dry HCl not changes the color of dry litmus paper? Again answer is here. So in the dry HCl, H plus ions will not be, which see, H plus ions are responsible, H plus ions are H2O plus ions are responsible. In dry HCl, these ions will not be. That's why dry HCl can't exhibit the what's our acidic property. Try to understand. Okay, acidic property is due to what's our due to what we can say due to the H plus ions or H3O plus ions. Now come to the next question. So what is the next question, sir? So why does this completed? While diluting acid, why it is recommended that acid should be added to the water, not water to the acid. As we discussed here, this is an which reactions are exothermic. If we are adding acid to the water, whatever local it produced here, it will make the remaining acid molecules to splash out. It may causes breaking of this container, or it may causes what's burns also, may burns our skin also. Okay, so this is the reason why we should, while why you should add the concentrated acid to the water during the dilution, that too with the stirring. Okay, so how is the concentration of hydronium ions affected when the solution of acid is diluted? What happens are, number of H plus ions, or we can say H3O plus ions per unit volume is going to decrease. Per unit volume will be decreased. Now, how is the concentration of hydroxide ion affected when the excess base? They are asking here. They are adding excess base. Excess base means what, sir? They are adding again more and more OH minus ions are going to add. It means OH minus ion concentration. This box represent concentration number is going to increase. That's why basic character may also be increases. Next concept. What is next concept, sir? How strong acids are basis solutions. So now see here. Just before this, you should know what you mean by uh, universal indicator. So let me explain a little bit. Okay, universal indicator is an indicator where we can able to identify different type of acids and bases. So you can see universal indicator. So universal indicator is what we can say. We can say it's an mixture of many mixture of many indicators. Okay, which is which is used to differentiate which is used to differentiate, we can say, like acid see, normal indicator can explain about acid or base. Now this universal indicator it will explain about strong acid, weak acid. Okay, similarly strong base, weak base. This also can be explained. I mean, sure, explained by the what's the universal indicator. Just to discuss about this one. Again, definition. So we know acid base indicators used to distinguish between the, what we can say, sir, just distinguish between the, what we can say, acid or base. While we have also learned in the previous section dilutions and decreasing the concentration of H plus ion, OH minus ions in solutions, can we quantitatively find the amount of these ions? Which ions are, what ions we discussed? We discussed H plus ion. We discussed which ions are OH minus ions. They're asking to count. Is it possible to take count of these things that we discuss? Okay, present in the solutions. Can we judge the how strong given acids and bases is? Okay, we can do this by making the use of universal indicator, which is a mixture of several indicators. The universal indicator is show the different colors at a different concentration of hydrogen ions in the solution. So what is the specialty of this indicator, sir? This explains about, universal indicator will explains about what, sir? Explains about what, sir? Concentration. Concentration means what, sir? Nothing but how many H plus ions are there? How many H plus ions are there? What number of H plus ions? Okay. So then after, let's discuss here. So the scale for measuring hydrogen ion concentration in a solution is called pH scale. Is developed. So universal indicator, we have one more thing called as pH scale. This pH scale also will same work. By using pH scale also, we are going to find out how many H plus ions are there, or how many OH minus ions are there. Okay, this is the specialty of pH scale. So here pH means power of power of H plus ion concentration. Okay, it can be written as pH is equal to negative log of H plus ion. This box represents what's our concentration. Okay, and as you see that, it's what they given to discuss. Okay, now see, they given that a scale for the measuring hydrogen ion concentration in a solution called pH scale has been developed. The P in the pH stand for potence in the German, meaning power. On the pH scale, we can measure the pH generally from 0 to 15. 0 to 14. So why it is 0 to 14? This question should arise in your mind. So what they are saying, sir, they are saying they are saying pH will lies between 0 to 14. What is the question? Why it is 0 to 14 only? The thing is to understand something. We have KW. This KW is something they'll call dissociation constant of water. They will say, see, when we are taken 1 liter of water, 1 liter of 1 liter of water. What happens? 1 liter of water at 25 degrees Celsius. At 25 degrees, what we should do, sir, with this one actually? If I can understand, about number of moles is equal to given given mass divided by molecular mass. Which molecular mass? Gram molecular mass. What is the given mass, sir? You know very well. 1 liter is equal to 1000 ml is equal to what's sir? 1000 grams. Why, sir? It is because density is equal to mass by volume. So they given in terms of ml, right? Volume they given. We need to convert into what's our mass, because here we have a mass, right? Now mass is equal to what, sir? Mass is equal to density into volume is equal to mass. What is the density of water? This is 1. That's why 1 into 1000 ml is equal to 1000 grams. Not in case of all other liquids. It is in case of what, sir? Water. Now see, given mass is how much, sir? We got as 1000 grams, sir. Okay. What is the gram molecular mass? We find out. Gram molecular mass. Water formula is H2O. So how many hydrogens are there? 2 into hydrogens are there. Mass is 1. Plus how many oxygens are there? 1 oxygen is there. What is the mass number? 16, sir. Is equal to 2 into 1, 2 plus 16 is equal to how much, sir? 18 AMU. Means what, sir? This is mass of one molecule of what, sir? H2O. What do you mean by grams, sir? Gram means what, sir? 1 mole H2. 1 mole H2 is equal to how many, sir? 18 grams, not 18 AMU. Remember. So now if you take an 18 grams, so 18 grams will get approximately 55.55 moles. So just remember, 1 liter of water contain how many moles of water, sir? It contain 55.55 moles. It means that if you are drinking 1 liter of water, just remember you are drinking 555.55 into 10 to the power of, sorry, 6.023 10 to the power of 23 H2O molecules. Right, understand? 6.5.5 555 point 10 to the power of 23. Those many molecules of water are entering your body. Okay, let it be water, maybe the things. This is not our content actually. So just think like these many molecules, these many moles of water are there in the 1 liter of water. Okay, now see, if I taken these many, how many? 55.55 moles of water contain, yes, sir, contain 25 degrees Celsius. How many, sir? 1.0 into 10 to the power of minus 7 H plus ion, and it contain 1.0 into 10 to the power of minus 7 OH minus ions. So what are the combinations total? It is 1.0 into 10 to the power of minus 14. This they can write as what, sir? They can write 10 to the power of minus 14. That's why pH is lies from 0 to 14. If suppose if pH is 0, suppose pH is 0, it means 0 ions. pH is 1 means it indicate that 1.0 into 10 to the power of minus 1 H plus ions are there, plus 1.0 into 10 to the power of minus 13. What will be, sir? OH minus ion will be there. Now tell me which ions are more, sir? Which ions are more? So answer is, my dears, remember this H plus ions are more. Which ions are more, sir? H plus ion. Why, sir? Because you see, 10 to the power of minus 1. 10 to the power of minus 1 is greater than what, sir? 10 to the power of minus 1 is greater than 10 to the power of minus 13. Don't think that this is highest number. This is an highest number because negative values are there. Let it be. So I think you got the point why this pH is like 0 to 14. Right? So now, you can see, I think we got the point why pH is like between 0 to 14. Now see, pH should be, suppose you remember here again, pH is 0 to, you can say 0 to 6.9, you can say it will be an acid. Similarly, pH, if it is 7.12 between 14 degrees and what's that, is an base, remember. Okay, exactly 7 means you're calling as a neutral, remember. Okay, so now see, pH should be an thought of simply as a number of numbers as which indicate the acidic or basic nature of solutions. Higher the hydronium concentration, lower the pH. So here you see they given here something else. Higher the pH, what we can say, sir? Higher the pH, so higher the pH. Remember here, pH is inversely proportional to the H plus ion concentration. This you please remember. If pH is more, then it means what, sir? H plus ion concentrations are less. Okay, let's understand. It's discussed. Okay, see, both are inversely proportional. Both are inversely proportional. Please remember. Okay, now see, just remember pH 0 to what I said, 0 to 6.9, it will be an acidic, we can say. Similarly, if it is 7.1 to 14, we can say the outside is an basic, and exactly 7 means we can say it will be an neutral. Let's remember here. One more thing is 14 pH values are there. 14, what we can say, 14 colors are there. 14 colors for the 14 values. You can see here. So they given here. So you can see this diagram, you try to understand it. You see here, you can see this zero pH is 0 here. It means you see this portion and indicate words are more H plus are there. You see pH is here, 14 is there. See what about concentration of H plus are here, very less. So we can say here OH concentration is more than the H plus ion concentration. Where, sir? In this portion. Here what we can say, here we can say H plus ion concentration is more than the what, sir? OH minus ion concentration. You see here what we can say, this portion I can say concentration of H plus ion is equal to concentration of OH minus ion. Okay, this blue color indicates H plus ion concentration. As pH, you can see it, as pH is increasing, the portion of this H plus ion concentration, which is blue color, is going to decrease. Similarly, as pH is increases, OHN concentration is also going to increase. So I can say POH is directly proportional towards the OH minus ion concentration. pH. pH is directly proportional to it. pH is increases, not pOH. Again, I am saying pH, not pOH. Okay. So now next to see what they given here. So after this one, you see, can see that they given different test the pH values of the solutions are given, and you can get the answers and all things here. So now see, you can see here. So we can see here. So 0 is what is the color here? You can see red color is there. Somewhat the dark red, you can say it is 7 is a green color, pale green color. You can see this is generally, you can say, purple color actually. This is in blue, so generally it is turning the red to blue color. Purple, we can say a slight yellow. That means this pH is 2.2, gastric is diluted CL is in our body is 1.2 approximately. Pure blood will be, again pure water blood will be 7.4, slightly alkaline. Milk of magnesia is also mild base, it is mild base. So one more thing I forgot to say, 0 to 3 we can say strong. So better I can write here. Okay, so now again little bit, see what I'm saying here. Suppose pH is lies between 0 to approximately 3 or 3.5, we can say it belongs to strong acid. Similarly, 3.5 to 6.9, we can say weak acid. Weak acid. Similarly, I can say 7.1 to 11, we can say it's a weak, or we can say mild base. Mild base it is. Similarly, suppose 11 to 14, we can say it's a strong. It is a strong base. Do you know what is another name for strong base? We can say alkalis. Generally, strong bases are soluble in the water, so we can call them as a alkali also. This will please remember. And after you can see, they given about pH, important of pH in our daily life. So you can see the given are plant animals, or what they given here, plant and animals are pH sensitive. See, body work within the pH range of 7.0 to 7.8. What we can say, it is an neutral to slightly, neutral to, what we can say, slightly alkaline. Okay, so this is a pH. Living organism can be survive only in this organism. pH of, and the pH of rainwater. So this question they asked in the 2024, 2024. I understand which one is pH, or this as MCQ they asked. Okay, so now see what they are saying. So suppose pH is less than 5.6, it will be called, what they are saying, sir, acid rain. Suppose what happens, sir, if it is rain will become acid, and it will be reaches the river, what we can say, water bodies. Okay, water bodies. So this, suppose you, this acid is reaches the water, what happens immediately is this, suppose this acid will start to produce what, sir, more H plus ions. More H plus ion means what, sir? pH is going to decrease. If that pH decreases less than 5.6, then it is called acid rain. So we know very well. So different gases are there. Let me write here. Suppose you think like there is an carbon dioxide gas in the atmosphere. It, concentration has become more and more. You think percentage of CO2 is more in the water. It forms something called H2CO3. Which acids are, do you know? If I don't name this, this is carbonic acid. Which acid is a carbonic acid. Okay, this carbonic acid, when it is reaches the water body, H2CO3 start to produce two H plus ions and one CO3 minus two ions. So these ion concentration is going to increase. So which makes the increases H plus ion concentration, so that we can say pH is going to decrease. Both way, because both are in this condition. What they are saying here, in this condition, when acid rain is falls flows into the rivers, it lowers the pH of river water. The survival of aquatic life in such a rivers becomes difficult. Aquatic life in such a rivers. Okay, so try to understand. This is what cause of acid rain in the water, aquatic animals, upon the aquatic animals. The pH of inner soil in the backyard. Okay, to understand. Okay, so something else, plant required specific pH range for their healthy grow. To find out pH required for the healthy grow, plant of your plant, you can collect the soil and it's blah 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 they given. Okay, so here generally what they will do, if you think, let me brief it. Okay, now see, simple thing is what they will do. They will take the steel will be there, and they will take around 2 grams of soil. 2 grams of soil they will take, and we have this is thing like a test tube, and 2 grams of soil they taken, and here they added around 10 ml of water. 10 ml of water to it, and we taken 2 grams of soil. Okay, 2 grams of water soil. And after sometimes they will leave for certain 2 3 hours, around not 2 3 hours, 2 3 hours we think, 2 3 hours, and then they will take a pH paper, and they will take a pH paper. This pH paper color, generally it will be an yellow color. Which colors are yellow color? Okay, so yellow color it is. Now after 2 3 hours you get a solution. What they will do, again they will take, again they will take Let me think here. So here they will take that whatever soil mixture they want here. They will take funnel here, and they will take the filter paper, and they will go for the filtration process. They will go for the filtration process. Now they will get a filtrate here. They will take filtrate, and this filtrate they will take in the again the beaker. Okay, and they will take this paper. Which paper? pH paper. Which is what is the color of pH paper, sir? It was a yellow color. Which color it was? A yellow color. Okay, this yellow color will turn somewhat which color, sir? Suppose you think like this yellow color paper turned into red color. Yellow color turns into which color, sir? Red color. Okay, so if it is turns into red color, if it is turns into red color, what it indicates are if it is turns into red color, try to understand pH will be less than what we can say 7, or we can say then the red means what we can say it will be an acidic soil. It will be an what's that? Acidic soil. Okay, now what kind of remedy we can take, sir? What kind of remedy we can take? Simple thing is after testing these are all things that I can understand. If it is acidic soil, soil is acidic soil, then we should add the base, basic substance. How we can add base? Like we can add CaCO3, which is called limestone. Limestone they can add, and they can add calcium hydroxide. Calcium hydroxide is called slaked lime, slaked lime, or sometimes I will add the CA walls. So CA walls is also it is called quick lime. Okay, quick lime. Any of these three we can add. Okay. Now, after doing this all, this is about story of what, sir? This is a story of what we can say story of we got acidic soil. Now think suppose if we got suppose we got basic soil. Then what we can say basic soil means what we should add, sir? We should add the acidic substance. This can be added by this compost. Compost we can add, or we can say we can add the organic manure. If the question will be asked, the farmer is adding these all things for the soil. And what is the nature of soil, sir? It is acidic. If farmer is adding this compost and manure means what is the nature of soil? It will be an basic soil we can say. Okay, na? This in this way we can understand these all things. Now come to the pH in our digestive system. pH in our interesting thing, and this blah 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 hydrochloric acid is there and it occurs. Okay, now see digestive systems how it is going to work here. Okay, so you know very well about in our stomach. Time to time there is an production of what we can say dilute HCl is going to be produced. I think we discussed just now, which is pH is approximately equal to 1.2. Okay, now see, this is it will produce time to time, right? Suppose if we are not having the food, what happens? This will become excess. Why it is becoming necessary? See, the purpose of production of this HCl is to decompose the food, right? In our body, we are intaking the food, right? So this dilute HCl will be help to break down that food actually. Okay. So when we are not taking food since from morning, suppose you think like didn't have a food. So in that what happens, sir? This excess amount of HCl will start to itch your stomach, wall of the stomach. Okay, wall of the stomach. So to overcome that one, we need to neutralize these all things. Okay, how we can neutralize? We can take the something called milk of magnesia. Formula is MgO8 taken twice. This is milk of what, sir? Milk of magnesia. Milk of magnesia. Remember, okay, this is called. This is also called ant antacid. Remember, means what, sir? Anti acid. Don't think that antacid means it's acid. It's an antivirus, antivirus like that. Anti-acid means opposite to the acid. It must be what, sir? It must be base. Remember. Okay. This one we can take, or we can take remedy as a NaHCO3. What it is, sir? This is called something called baking soda. baking soda. One more we have something called ZnCO3. Okay, this is called calamine. These all things we can use as a what's a remedy for the excess production of HCl. What happens here? Let me write the reaction. Okay, think you please try to understand what is exact meaning of neutralization. Okay. Just we just said that we can take milk of magnesium so that you can neutralize the HCl actually. How it is possible? Actually, we try to think actually. Now see here. Now we are taking here HCl and MgOH. See first is HCl will produce what sir? HCl will produce something called H plus ion. What will produce sir? H plus ion they will produce. Similarly, magnesium hydroxide will produce what sir? OH minus ions. OH minus ions. And you tell me let me clarify this is HCl is going to show what's her acidic property because of what actually because of what's her H plus ion because of H plus ion until and unless it have H plus ion there is an acidic behavior. Similarly, until and unless this OH minus ion this milk of magnesia will show the basic property. Now these two will undergo what's our neutralization H plus from the acid H plus from the acid. Similarly, OH minus from the base. These two will neutralize. It will become what's our H2O. And remaining what it is our remaining we have a magnesium chloride salt. This is salt. Salts. Okay, no matters whatever may be the salt. You try to understand. See, cause for the acidic nature is which one, sir? This is H plus N. Now cause for the basic character words are this will be an words are OH minus ions. When these two will combine, they forming new substance. This is new substance means what we can say sir completely whatever earlier property they have completely they are vanished out. That's why here once S2O is going to form there is no what we can say behavior of acidic character or we can say basic character completely those properties are completely we can say destroyed we can say. That's why it is called a neutralization. No more acidic property, no more basic property, both are nullified, cancelled, neutralized each other. That's why it is called dissolve. Whatever till now we discussed these are called what's the neutralization reactions. Okay, now let me go for the next one. pH as cause of tooth decay. They given here something called pH of mouth. They given how much sir? It is 5.5 pH. Sorry, tooth decay starts when pH of mouth is lower than the 5.5. If pH is 5.5 के नीचे रहे तो क्या हो जाएगा टूथ डिके हो जाएगा. सी इसके पहले टूथ डिके tooth enamel made up of calcium hydroxyapatite. Calcium hydroxyapatite. So let me write first. It is a crystalline form of calcium phosphate. So I think I hope so. You people know about calcium phosphate. Okay, calcium phosphate. So in the first video we discuss about chemical formula, outright chemical formula. You see here, calcium. What is the calcium symbols are Ca. Charge is what sir? +2. So phosphate what sir? Phosphate is PO4. What is charge upon phosphate sir? -3. Now see, take this charge. Take this charge. Take this charge as what sir? Take discharge as a valency. You can see here 2 is a valence. Yes, what is charge here? 3 is a valence. Exchange these numbers, then what will get sir? We will get the formula of Ca. How many times sir? 3 times Ca3. PO4 how many times sir? Taken bracket immediately into. This is the formula of calcium phosphate with there are 10 molecules of I think so water molecules will be there. That is called hydroxyapatite. Hydroxyapatite means there is an water or we can say OH will be there. Okay. Okay. So here it does not dissolve in the water but it is corroded when pH of mouth is below the 5.5. Bacteria present in the mouth produces acids by degradation of sugar and food particles remaining in the mouth after eating. Best way to prevent this is clean our mouth after eating food using toothpaste, which are generally basic. Again, what we have, sir? Here we have acid. Because of which, sir, acid, sir? Because of some bacteria, it seems. Bacteria will produce acid. Morning we are going to take a what you call brush, which contain base. Both will be again neutralized. It is neutralized. If not, tooth decay is going to occur. Okay, that is the reason why we need to take brush after eating, or we can say morning. Self defense by the animals and plants through the chemical warfare. Self defense हो जाएगा. Okay. Self-defense. So printing here. So self-defense by the animals and plants. Plants and animals be self-defense कर जाएगा कैसे? So so stung. See how you are stung by the honeybee? Yes, definitely. Bee sting leaves an acid which causes pain and irritations. Use the mild bases like baking soda and stung area gives relief stinging. Stinging area of the nettle leaves inject methanoic acid causing burning pain. Methanoic acid. Methanoic acid बोले तो क्या जी? Methanoic acid. Think we gone through the chapter called Carmen's compounds. Here we have C double bond O with OH, and here H is there. This is called, how many carbons are there here, sir? We have a one carbon. One carbon means the root word is METH. Written here METH because of only one carbon. Similarly, single bond between carbon to oxygen. Sorry, generally it is called AN. You see, this is called carboxylic group here. COH is that. This is called as by OIC acid. This is the formula of what's the methanoic acid. What is the formula? HCOOH. This is the formula. This can be neutralized by what they are saying, sir, mild base. If it is stung by the honeybee or hamstring, we need to rub with that area with a mild base. Solution of mild base. It means what, sir? Solution NaHCO3 solution. NaCO3 solution means aqueous solution. Then what happens, sir, here? Just let me write here reaction bit downside. Okay, so I'm writing here. So there is an HCOOH plus there is an base called mild base called what's that? NaHCO3 aqueous solutions. So what happens, sir? Acid H plus N, base what's that? OH minus N. See, one more thing is try to understand here. There is an CO3, definitely right side there will be an CO2 plus there is an what's that? We can expect HCOONA plus H2O. Neutralization reaction is completed. Now this compound names are, which is called, generally this is also called formic acid. For formic acid, so we can say name of the compound is salt is what's a sodium formate. Sodium formate. Okay, sodium formula is what's a HCOONA. This is about what's a, this is about neutralization reactions when an ant sting or honeybee sting will be left in our skin. We need to rub with an solution of mild bases. Again, I'm saying mild bases. We should use mild bases. Should not use the strong bases because they are. If I can't use NaOH because it is a corrosive, instead of giving remedy, it can causes what is our burning of skin. Now see, like even let us something else. There is one more bee will be wasp bee. Remember, it is nowhere explained actually. There is a wasp bee which will produce base on biting. Okay, this can be neutralized by what's that? This is a mild acid. Like what's like CH3 COOH. What it is nothing but vinegar. So please keep in your mind. Okay, so this is about a neutralization reaction. They given a question, so we can discuss something else better so that we can wind up. You have two solutions. Okay, two solutions are there. A and B, it seems. A is there and B is there. So pH of A is what, sir? pH is 6 and pH of B is what, sir? 8. It is again pH. Okay. Which solution has more hydrogen concentration? We know very well pH is inversely proportional to the H plus ion concentration. pH is more means the value should be less. Definitely. So this is pH. We can write pH of A is less than the pH of what, sir? B. Which one have lesser? A. So A have a more H plus ion concentration than the H plus ion concentration in solution B. Okay. So which is acidic, which is basic, sir. The pH is 6 means that definitely less than 7. It is acid. pH is 8 means more than it is, and what's the base it is. What effect does the concentration of H plus ions have in the nature of the solution? So more number of H plus ion, it will be acidic in nature. Okay, let's remember, as H plus ion concentration increases, acidic nature of solution also going to increase. Do the basic solutions have H plus ions? If yes, then why that bases? So simple thing is here. See here, every solutions maximum they have both H plus ion concentration as well as H plus ions as well as OH minus ions. Suppose if H plus ion concentration is more than the OH minus ion concentration, then it is called, what you call, sir, it is acid. Suppose if it is vice versa, OH minus ion concentration is greater than the H plus ion concentration, it is called what? It is called base acid is. Okay, because OH minus ion means more, means it can, we can say there will be an more base. Okay. Now, say next we can discuss about one more question is there. So, under the soil condition, what condition, under the what condition of soil do you think farmer would have treat the soil of quicklime? We discussed always lake lime and calcium carbonate. What is the conditions are when pH is less than 7? It means when there is an acidic soil, these all are the bases. Calcium hydroxide is all should treat this thing when the soil is acidic in nature. Okay. So thank you for watching. So like we discuss about salt. Okay. We'll discuss salt about salt in next video. Thank you. Thank you for watching.